fact one, the constant motion even as you hear these words. In a moment that feels perfectly calm and still, you are part of a grand and silent cosmic journey. You are, at this very second, moving through the vastness of space at a speed that defies imagination. Nothing could have prepared astronomers for the true complexity of this motion. A series of interwoven movements that carry our planet, our sun, and our entire galaxy through the cosmos. This fact defies every prediction our senses make about our place in the universe. What exactly are these motions? And why do we feel so perfectly still while hurtling through the void at over 500,000 miles per hour, or 820,000 kilometers per hour? The first layer of this incredible movement is the rotation of the planet Earth itself. This is a motion we are all part of, yet it remains completely unnoticed in our daily lives, as our planet spins on its axis, completing one full turn in approximately 24 hours. It gives us the familiar cycle of day and night. At the equator, the surface of the Earth is moving at a speed of approximately 1,000 miles per hour, which is about 1,670 kilometers per hour. This speed is faster than most modern jets, yet we feel nothing. We are not swept off our feet, and the air is not a constant hurricane. This is because the planet's motion is almost perfectly constant, and everything on its surface, including the oceans and the very atmosphere we breathe, is moving along with us. It is like being in an airplane, traveling at a smooth, constant speed. You do not feel the velocity, only the changes in it. But this gentle spin is only the beginning of our journey. The Earth itself, this grand, silent spaceship, is not stationary in space. It is in a constant state of motion, bound by the immense gravity of our parent star, the Sun. The Earth travels in a gigantic, almost circular path, an orbit around the Sun, to complete this journey, which defines 1 year. Our planet must travel at an incredible velocity. This speed is approximately 67,000 miles per hour, which corresponds to roughly 107,000 kilometers per hour. This motion, far faster than our planet's spin, is also completely undetectable to our senses. We are in a state of continuous free fall around the Sun, balanced perfectly by our own forward momentum. This is the same principle that keeps astronauts in orbit around the Earth. They are constantly falling, but also moving sideways so fast that they continuously miss the planet. We, too, are falling around the Sun, passengers on a world that is silently screaming through the solar system. Even the staggering speed is dwarfed by the next, and perhaps most profound, layer of our cosmic motion. The Sun itself, the anchor of our solar system, is not a fixed point in the universe. It is a star, one of hundreds of billions, that belongs to the vast spiral galaxy we call the Milky Way. Just as the Earth orbits the Sun, the entire solar system orbits the center of our galaxy. At the heart of the Milky Way lies a supermassive black hole, a gravitational monster known as Sagittarius, whose mass is millions of times that of our Sun, pulled by this immense gravitational force. Our Sun and all its planets are sweeping through the galaxy in a long, slow orbit that takes more than 200 million years to complete. Our speed in this grand galactic orbit is an almost unbelievable 515,000 miles per hour. This motion is the primary component of our journey through the cosmos, the silent rush of our entire star system through interstellar space. When we combine these velocities, we arrive at the astonishing truth of our existence. While sitting perfectly still, you are on a planet spinning at 1,000 miles per hour, which is orbiting a star at 67,000 miles per hour, which is itself orbiting a galaxy at over 500,000 miles per hour. These motions do not simply add up as they point in different directions in complex three-dimensional space, but they paint a picture of a universe that is anything but static. We are all travelers. We are passengers on a pale blue dot, part of a solar system, itself a tiny member of a galaxy, all moving in a silent, coordinated dance that began billions of years ago. It is a testament to the laws of physics that we can feel so perfectly at peace, so completely still, while participating in one of the most magnificent and rapid journeys the cosmos has to offer. The feeling of stillness is an illusion, a beautiful consequence of harmony and constant velocity, masking the true and constant motion that defines our place in the universe. Fact 2. The blue sunset on Mars, on our own planet Earth. The end of the day is often a moment of breathtaking beauty. We watch as the sun dips below the horizon, painting the sky in a dramatic spectacle of deep reds, vibrant oranges, and soft purples. This daily phenomenon is a familiar comfort, a result of our planet's thick atmosphere and the physics of light. But nothing could have prepared astronomers for what spacecraft would one day reveal on our nearest planetary neighbor. When our robotic explorers first sent back images from the surface of Mars, they showed us a world that was both familiar and profoundly alien. They revealed a sunset that defied every expectation, a sight that rewrites the rules of twilight. What exactly do these rovers see? And why, on a planet defined by its red dust, are the sunsets a dusty, pale blue? To understand this strange and beautiful Martian phenomenon, we must first look at our own world. The colors of an Earth's sunset are a direct result of our atmosphere, a deep and dense blanket of gas that surrounds our planet. This atmosphere is composed of countless tiny molecules of nitrogen, oxygen, and other gases. When sunlight, which contains all the colors of the spectrum, enters this atmosphere, it interacts with these molecules. This process is known as Rayleigh scattering. The shorter wavelengths of light, the blues and the violets, are scattered more easily and in all directions. This is what makes our daytime sky blue. But at sunrise or sunset, the sun is low on the horizon, and its light must travel through a much thicker, longer slice of the atmosphere to reach our eyes. By the time this light gets to us, most of the blue and violet light has been scattered away, leaving only the longer wavelengths, the reds and the oranges, to pass through. When we turn our gaze to Mars, we are looking at a fundamentally different world. The fourth planet from the Sun is a cold, desert world, and its most defining feature is its atmosphere. The Martian atmosphere is incredibly thin, a mere whisper compared to our own. In fact, its density is only about 1% as thick as the atmosphere we experience here on Earth, because the air is so thin. With so few gas molecules, the effect of Rayleigh scattering, the process that makes our sky blue, is almost non-existent. The daytime sky on Mars is not blue. Instead, it is a pale, dusty, reddish pink, often described as butterscotch or salmon. This color comes not from the air itself, but from what fills it: dust. Mars is a world covered in fine, iron-rich dust, and this red dust is constantly kicked up into the atmosphere by winds. This fine red dust is the key to understanding the Martian sunset. The physics of this scene is governed by a different process. The dust particles are much larger than the gas molecules in Earth's air, and they scatter light in a different way throughout the Martian day. These fine dust particles are the perfect size to absorb blue light and scatter the red light across the sky, which is why the sky itself appears reddish. But as the sun begins to set on Mars, the light must, just like on Earth, pass through more of the atmosphere. However, on Mars, this means passing through more of the fine dust. As the light travels through this thicker layer of dust, the red light is scattered away from the observer's direct line of sight. The blue light, which is not scattered as much by these specific dust particles, is able to pass through more directly. The result is that the area of the sky immediately surrounding the setting sun appears to glow with a faint, hazy, and pale blue color, while the rest of the sky darkens to a reddish gray. It is a haunting and subtle display, the exact opposite of an Earth sunset. This phenomenon, captured by rovers like Spirit, Opportunity, and Curiosity, is more than just a photograph. It is a glimpse into the delicate physics of another world, a calm reminder that the universe is full of wonders that challenge our earthbound intuition, painting the close of a Martian day in a color we least expected. Fact 3. The king of storms on Earth. We are familiar with the power of storms. We have witnessed hurricanes with ferocious winds and thunderstorms that shake the ground. Yet these events, so powerful to us, are temporary. They are born, they spend their energy, and they die, often within days or weeks. But far away in our solar system, on the largest planet that orbits our sun, there exists a storm so vast and so ancient it defies our very understanding of weather. This is Jupiter's great red spot, a swirling, mysterious vortex that is larger than the entire planet Earth. It is an icon of the solar system, a deep red eye staring out from the clouds of a gas giant. This remarkable feature has been raging for centuries, a colossal tempest that has outlived the empires of humanity. What exactly is this storm, and how has it managed to survive for so long? The great red spot is a storm of almost unimaginable scale. When astronomers first began observing it in detail, they were staggered by its size. Recent measurements from spacecraft showed that the storm is approximately 10,150 miles wide, which corresponds to about 16,350 kilometers. At this size, the entire planet Earth could be dropped into its swirling clouds and would be swallowed whole. It is a high-pressure system, technically known as an anticyclone, which rotates counterclockwise in Jupiter's southern hemisphere. This single storm is the largest and most powerful in the entire solar system, a testament to the immense energy contained within Jupiter, a planet so large it could hold all other planets within it. Its color, a deep shades of red, orange, and crimson, is itself a mystery. Though scientists believe it may be caused by complex chemicals from deep within Jupiter's atmosphere being dredged up and exposed to ultraviolet light from the Sun. Perhaps even more astonishing than its size is its incredible longevity. This is not a storm that was born last year or even last century. It has been raging for at least 300 years, while its exact origin is unknown. Astronomers like Giovanni Cassini in the 1600s reported seeing a permanent spot on Jupiter, which many believe is the first recorded observation of the Great Red Spot. This means this single storm has been swirling continuously since before the Industrial Revolution, before the founding of many modern nations. It is a swirling, ancient feature that has outlived empires and generations. This longevity is possible because Jupiter is fundamentally different from Earth. Our planet is a world of rock and water. When a hurricane on Earth moves over land, the friction from the surface robs it of its energy and moisture, and it quickly dissipes. Jupiter has no solid surface. It is a gas giant, a world of deep, dense clouds. The Great Red Spot is a storm of gas, floating in an ocean of gas. With no land to slow it down, it is free to rage on, trapped between two of Jupiter's powerful jet streams that flow in opposite directions, helping to spin the vortex and keep it stable. The power of this storm is as impressive as its size and age. Observations from spacecraft, most recently NASA's Juno mission, have measured its wind speeds. The winds at the edge of the storm are ferocious, consistently reaching speeds of over 400 miles per hour, or about 650 kilometers per hour. This is more than twice as fast as the most powerful Category 5 hurricanes ever recorded on Earth. It is a swirling debris, an ancient and lonely vortex, all alone in the vast gas clouds of the giant planet. For centuries, it has been a symbol of the dynamic and violent nature of the outer solar system, though modern observations show that the storm has been shrinking over the last few decades. It remains a colossal feature. The Great Red Spot is more than just a weather pattern. It is a cosmic monument, a storm that has outlasted generations, reminding us of the immense scale and timeless forces that shape the worlds beyond our own. Fact 4. The moon's slow escape for millennia. Humanity has looked to the sky and seen a constant, faithful companion in the moon. It has been a symbol of permanence, a keeper of time, and a silent witness to the entirety of human history. Its gravitational pull commands our oceans, creating the rhythmic pulse of the tides. But nothing could have prepared astronomers for the staggering realization that this relationship is not forever. This celestial dance is in fact an evolving story, and our moon is slowly, almost imperceptibly, saying a cosmic goodbye. What is the mechanism behind this steady escape, and what does it tell us about the deep, dynamic past of our own planet? The truth of the moon's departure was not uncovered with ancient telescopes, but with one of the greatest achievements of the modern age. When the astronauts of the Apollo missions, specifically Apollo 11, Apollo 14, and Apollo 15, visited the lunar surface between the years 1969 and 1971, they did not just collect rocks and plant flags. They left behind a series of remarkable scientific instruments known as the Lunar Laser Ranging Retroreflector Arrays. These are essentially sophisticated mirrors, designed to reflect beams of light back to their source. From Earth, astronomers at observatories like the McDonald Observatory in Texas can fire powerful laser beams at these mirrors. By measuring the precise time it takes for the laser light to travel to the moon and return, they can calculate the distance to the moon with an accuracy of just a few millimeters. It is through these decades-long persistent measurements that the astonishing truth was confirmed. The data is undeniable. The moon is moving away from the Earth at a rate of approximately 1.5 inches, or about 3.8 centimeters every single year. This pace may seem unremarkable, roughly the same speed at which a human fingernail grows. But in the vast time scale of celestial mechanics, it is a profound and dramatic change. The slow escape is not a random drift, but the direct and unavoidable consequence of the gravitational dance between the Earth and the Moon. The process is known as tidal acceleration. It begins with the Moon's gravity, which pulls on the Earth, particularly on its vast oceans. This pull creates two tidal bulges, one on the side of the Earth facing the Moon, and one on the side directly opposite. However, the Earth rotates on its axis much faster, about 27 times faster than the Moon orbits the Earth. This rapid spinning drags the planet's tidal bulges slightly ahead of the Moon in its orbit. Because these bulges of water contain an immense amount of mass, they have their own gravitational pull. The leading bulge, always just ahead of the Moon, effectively tugs the Moon forward. This constant, gentle pull of gravity acts like a small rocket booster, causing the Moon to accelerate in its orbit. As any object in orbit speeds up, it doesn't fall back to Earth. Instead, it climbs higher, moving into a more distant orbit. This is the mechanism of the escape. This entire process is governed by one of the most fundamental laws of physics, the conservation of angular momentum. The Earth-Moon system is a closed system, and its total rotational energy must be preserved, as the Earth's gravity pulls on the Moon to speed it up. The Moon's gravity pulls back on the Earth's tidal bulges, creating friction. This friction, known as tidal friction, acts as a brake on the Earth's rotation. The result is that the Earth's day is slowly getting longer. This transfer of energy is precise. The Earth loses rotational energy, slowing its spin, and that exact amount of energy is transferred to the Moon, pushing it farther away. The implications for our planet's past are staggering. If the Moon is moving away, it means that in the distant past, it was much, much closer. Billions of years ago, shortly after the Moon's formation, it would have been a colossal object in the sky, appearing perhaps 10 or 15 times larger than it does today. And the Earth's rotation was spectacularly fast. A day on Earth may have lasted only 6 to 8 hours. The tidal forces from this close, massive Moon would have been monumental, creating ocean tides, hundreds or even thousands of feet high, that swept across the young continents. Some scientists even theorize that this extreme tidal mixing in the early oceans was a critical ingredient in stirring the primordial soup, helping to foster the first emergence of life. Looking forward, this slow, steady separation will redefine our world's future. As the Moon becomes smaller and more distant, its gravitational influence will wane. Billions of years from now, the Moon will appear as a smaller, less impressive point of light. A profound consequence of this increasing distance will be the end of total solar eclipses. A total solar eclipse is a beautiful cosmic coincidence, possible only because the Moon, from our point of view, is at the precise distance to appear to be the exact same size as the much larger, more distant Sun. As the Moon drifts farther away, it will appear smaller, and it will no longer be able to completely block out the Sun's disk. Future inhabitants of Earth will only see annular or ring of fire eclipses. The perfect or inspiring totality we experience today is a fleeting gift, temporary in the grand scheme of cosmic time. This is more than just a fact. It is a glimpse into the dynamic, living nature of our solar system, a reminder that the heavens are not static, but a place of constant, majestic, and irreversible change. Fact 5. The light from the past when we stand on the earth and gaze into the darkness of the night sky. We are overcome with a sense of immediacy. We see the pinpricks of stars, the soft glow of the Milky Way, and the familiar face of the moon. And it all feels as though it is happening right now, in this very moment. But this is perhaps the grandest illusion in all of human experience. Nothing could have prepared our ancestors for the reality that the night sky is not a snapshot of the present, but rather a deep, layered look into the past. We are, in every sense of the word, looking back in time. Why is this? And what does it reveal about our place in the cosmos? The answer lies in a fundamental, immovable law of the universe, the speed of light. Light, though it appears instantaneous, travels at a finite and measurable speed. In the vast vacuum of space, it moves at an astonishing 299,792,458 meters per second, a speed often rounded to 300,000 kilometers per second, or about 186,000 miles per second. This speed is incredibly fast, but it is not infinite. Space is incomprehensibly large, and it takes time for the light from distant objects to cross the void and reach our eyes. Every single thing we see in the universe, we see not as it is, but as it was. At the very moment that light began its journey to us, this cosmic time delay begins in our own immediate neighborhood. The closest celestial object to us, the moon, orbits at an average distance of about 384,400 kilometers. The light reflecting from its surface, the light you see when you look at it, has traveled for approximately 1.3 seconds to reach your retina. If the moon were to suddenly vanish, we on Earth would have no idea for 1.3 seconds. It is a small delay, but it is real. Let us move to the center of our solar system, the sun, this blazing furnace, the source of all our light and life. Lies about 150 million kilometers away, a distance known as one astronomical unit. The light from the sun's surface does not reach us instantly. It must travel for 8 minutes and 20 seconds to cross that vast distance. The warmth you feel on your skin, the light that illuminates your day, is not from the sun as it is now. It is from the sun as it was 8 minutes and 20 seconds ago. Every sunset we watch is a ghost, a beautiful after-image of a star that has, from its perspective, already dipped below the horizon 8 minutes earlier. From there, the time scales become truly. Let us consider the nearest star to our own sun, a small red dwarf known as Proxima Centauri. It is our closest stellar neighbor, yet it lies more than 4.24 light-years away. A light-year is a unit of distance, not time. It is the distance that light travels in one single year, a journey of about 9.46 trillion kilometers. The faint red light we see from Proxima Centauri in the southern sky began its journey 4.24 years ago. When we look at it, we are seeing it as it was during a previous time in our own lives. If a civilization on a planet orbiting that star were to send us a message today at the speed of light, we would not receive it for 4.24 years. And our reply would take another 4.24 years to return. But that is just our nearest neighbor. Let us look farther, to an object visible to the naked eye on a clear, dark night. In the constellation Andromeda, there is a faint, fuzzy patch of light. This is not a star, but an entire galaxy, Messier 31, also known as the Andromeda Galaxy. It is a spiral galaxy, much like our own Milky Way, a vast island of hundreds of billions of stars. This galaxy is the most distant object the human eye can see without aid, and it lies 2.5 million light-years away. The light that you capture with your eyes when you look at Andromeda left that galaxy 2.5 million years ago. It began its journey across intergalactic space when our earliest human ancestors, hominids like Homo habilis, were just beginning to walk the earth and fashion the first stone tools. Those ancient ancestors could have looked up at the exact same patch of light, a phantom glow from a future that would not arrive for 2.5 million years. And this is only the beginning. Modern telescopes like the Hubble Space Telescope and the James Webb Space Telescope are designed specifically to exploit this phenomenon. They are time machines. When they look deep into space, they capture light from galaxies that are 5, 10, or even 13 billion light-years away. They are seeing light that began its journey when the universe itself was just a fraction of its current age, only a few 100 million years old. These telescopes are literally watching the first galaxies ignite, witnessing the cosmic dawn. We are not just seeing the history of the universe. We are seeing it unfold, layer by layer, with every increasing measure of distance. The night sky is not a static canvas. It is a time capsule, a cosmic history book where every point of light is a word from the past, reminding us that our present is built on an ancient, illuminated history. Fact 6. The longest journey for light, we look at our sun and see a brilliant, perfect orb. It is the very definition of constancy, a reliable furnace that rises and sets with perfect predictability, bathing our world in a steady stream of life-giving light. We know its light takes a mere 8 minutes to race across space and reach our planet. But this 8-minute dash is only the final, triumphant sprint of what is perhaps the most epic, ancient, and violent journey in the entire solar system. The light that warms your face today did not begin 8 minutes ago. It was born thousands of generations ago, deep within the core of the sun, and it spent millennia fighting to escape. This story begins in the very heart of the sun, a core of unimaginable density and pressure. Here, the temperature soars to 15 million degrees Celsius, and the pressure is over 265 billion times that of Earth's atmosphere. In this inferno, the sun's fuel, hydrogen, is not a gas but a plasma, a roiling sea of charged particles. Under this immense pressure, hydrogen nuclei are slammed together with such violence that they overcome their natural repulsion and fuse, forging a new element, helium. This process, known as nuclear fusion, releases a tremendous burst of energy. This energy is born as a particle of high-energy light, a photon, in the form of a gamma ray. This is the birth of our particle of light. In a vacuum, This photon would travel forever at the speed of light, but it is not in a vacuum. It has been born in one of the densest places in the universe. Its journey outward is not a straight line, but a brutal and chaotic struggle. This region, the vast inner part of the Sun, is known as the radiative zone. It is so densely packed with plasma, with charged electrons and protons, that the photon cannot travel for more than a few millimeters, sometimes as little as 1 centimeter, before it collides with a particle. It is absorbed by an electron, and then, a fraction of a second later, it is re-emitted. The problem is that it is re-emitted in a completely random direction. It might be sent sideways, or forward, or even directly backwards, back toward the core it just left. This process repeats over and over, billions of times per second. This staggering, drunken journey is known in physics as a random walk. The photon is like a person in a vast, dense crowd, trying to escape but being bounced in a different direction with every single step. Its net progress outward is agonizingly slow. With every collision and reabsorption, the photon also loses a tiny bit of its energy. The high-energy gamma ray that was born in the core is slowly downgraded, becoming an X-ray, then ultraviolet light, and finally, after countless eons, a gentle photon of visible light, the very kind we see with our eyes. This staggering million-step journey from the core through the 700,000-kilometer width of the radiative zone is what takes the time. Astronomers estimate that for a single photon to complete this random walk and finally reach the outer layers of the Sun, it takes, on average, 100,000 years. Some estimates place this journey even longer, as high as several 100,000 or even 1,000,000 years. The light that strikes Earth today was created before modern humans ever left Africa, before the last ice age, in a time ancient beyond all reckoning. After its long imprisonment in the radiative zone, the photon reaches the next layer, the convective zone. Here, the process changes. The plasma is cooler and less dense, and energy is no longer transported by radiation but by convection. Like a pot of boiling water, our photon is now carried in vast, rising columns of hot plasma, rising to the surface, cooling, and sinking back down. The photon is like a passenger in a massive, turbulent elevator. This part of the journey is much faster, perhaps taking only a few months. Finally, after 100,000 years of being trapped, bounced, and carried, the photon reaches the Sun's visible surface, a layer known as the photosphere. With one final push, it breaks free from the plasma, and for the first time in its long existence, it is in the near vacuum of space. There is nothing left to stop it. It begins its final journey, a straight, unimpeded dash outward at the speed of light. 8 minutes later, that same ancient photon, born of fusion 100 millennia ago, ends its epic journey by striking a leaf on a tree, or the surface of the ocean, or the retina of a human eye. It is a particle of light with a story of imprisonment and escape, a story of a 100,000-year odyssey, followed by an 8-minute sprint. It is a testament to the fact that even the simplest, most familiar things in our world are born from processes of unimaginable scale and time. Fact 7. The city-sized star in the grand and silent theater of the cosmos. The universe stages plays of unimaginable creation and destruction. We see the gentle birth of stars in vast, colorful nebulas, and we see them live for billions of years, as our own sun has. But nothing can prepare us for the sheer, mind-bending extremity of their death. When the most massive stars in the universe die, they do not go quietly. They explode in a cataclysmic event known as a supernova, an explosion so bright it can briefly outshine its entire galaxy. And after the dust and gas of this final, glorious outburst clears, something is left behind. This remnant, this cosmic tombstone, is one of the most bizarre, fascinating, and densest objects in the entire universe. It is known to astronomers as a neutron star. This object is the collapsed core of the giant star that just died. Its journey to this state is one of almost unbelievable violence. During the star's life, the outward pressure of nuclear fusion balanced the inward pull of gravity. But when the star ran out of fuel, that balance was broken. Gravity won. The core collapsed in on itself in a fraction of a second, crushing all the material within it with a force that defies comprehension. The gravity was so intense, so overwhelming, that it fundamentally changed the nature of matter itself. In a normal atom, electrons orbit a nucleus of protons and neutrons. But in this collapsing core, the pressure was so great that it forced the electrons and protons to smash together, merging to become neutrons. The entire star, a core that was once thousands of miles across, was crushed down until it was composed almost entirely of neutrons, packed together as tightly as an atomic nucleus. What makes this object so special is not just what it is made of, but its astonishing scale. While it began as the core of a star many times larger than our Sun, the final neutron star is incredibly small. Astronomers estimate that a typical neutron star is only about 12 miles across, or roughly 20 kilometers. This is the size of a city. Imagine an object that holds the complete compressed history of a giant star, but it would fit neatly between the downtown of a major city and its suburbs. It is a star that you could, in theory, drive around in an afternoon. But this tiny, city-sized object carries a secret. It may be small, but it is unbelievably heavy. The collapse did not destroy the star's mass. It only compacted it. A typical neutron star has more mass than our entire Sun. Some have been measured at 1.5, or even 2 times the mass of the Sun. All of that material, all of that immense weight, is squeezed into a perfect sphere no larger than a town. This leads to a density that is almost impossible to describe in human terms. It is the densest object in the universe that is not a black hole. To try and put this density into perspective, scientists have made a famous calculation. If you could somehow travel to the surface of a neutron star, which you could not, as its gravity would instantly flatten you, and if you could scoop up a single, ordinary teaspoon of its material, that one small spoonful of neutron star matter would have a mass of 6 billion tons. That is the weight of the entire human population, or a mountain, or a fleet of thousands of battleships concentrated into a space the size of a sugar cube. This is the nature of a neutron star. It is an object where the laws of physics are pushed to their absolute limit. It is a single, giant, atomic nucleus 12 miles wide, that weighs more than our sun. It is a silent testament to the power of gravity and a true monster of the deep cosmos. Fact 8. The kitchen blender star, the universe, is already full of extremes, and the neutron star, that city-sized object heavier than our sun, is one of its most remarkable creations. But the cosmos, in its infinite creativity, did not stop there. It took this impossibly dense object and decided to make it even more bizarre. It made it spin, and not just spin, but spin at speeds that shatter our understanding of motion. When these spinning neutron stars were first discovered, they presented one of the greatest mysteries in modern astronomy. They are known as pulsars, and they are the universe's most extreme timekeepers. Their discovery is a fascinating story. In the year 1967, an astronomer named Jocelyn Bell Bernal, then a graduate student, was monitoring data from a new radio telescope. She detected a strange, faint signal from deep space. It was not a steady hum, but a perfect, rhythmic pulse. It repeated with such unfailing precision, once every 1 1/3 seconds, that the team half-jokingly labeled it LGM1, for Little Green Men. They had to seriously consider if they had just discovered a signal from an alien civilization. But soon, more of these signals were found in other parts of the sky. This was not a message. It was a new kind of star. What they had found was a pulsar. This is not a new object, but rather a special kind of neutron star. When the giant star collapsed to form the neutron star, it conserved a principle known as angular momentum. This is the same principle an ice skater uses when they pull their arms in to spin faster. The star, which may have taken days to rotate when it was millions of miles wide, was crushed down to only 12 miles across. This catastrophic shrinking caused its rotational speed to increase to unimaginable levels. These spinning neutron stars also have immensely powerful magnetic fields, the strongest in the universe. These fields funnel radiation, like radio waves and X-rays, into two tight beams that shoot out from the star's magnetic pole. The star spins, and these beams of radiation sweep through space exactly like the beam from a cosmic lighthouse. From our perspective on Earth, we do not see a steady light. Instead, we see a pulse every single time that beam sweeps across our telescopes. The star is not actually pulsing. It is spinning, a celestial beacon in the dark. And the speed of this spin is what is truly breathtaking. Many pulsars spin several times a second, but astronomers have been hunting for the fastest of these objects, and the record holder is a pulsar known by its catalog name, PSRG 1748-2446 AD. This object defies all intuition. It is a city-sized star, heavier than the sun, and it spins 716 times every single second. This is not a typo. 716 rotations in the time it takes to snap your fingers. It is spinning faster than a kitchen blender. The equator of this star is moving at nearly 1/4 of the speed of light. If any normal object, even our own sun, tried to spin this fast, it would be instantly torn apart by centrifugal force. But the neutron star's gravity is so impossibly strong, so powerful, that it holds itself together, a tiny, hyper-fast, impossibly heavy object, beaming its rhythmic pulse across the galaxy for millions of years. Fact 9. the biggest star we know for millennia. Humanity has looked up at the night sky and seen the stars as small, faint points of light. We have learned, to our own amazement, that these are not small. They are suns, just like our own, but incredibly far away. Our sun itself is a colossal object, a ball of plasma so large that you could fit 1,300,000 Earths inside it. It contains more than 99% of all the mass in our entire solar system. It is the definition of giant in our world. But in the grander gallery of the cosmos, our sun is a speck of dust. The universe builds stars on scales that dwarf our imagination, and the largest star we have yet discovered is a true monster, a hypergent known as UY Scuti. This star is so enormous that it is genuinely difficult to comprehend. It is classified by astronomers as a red hypergent, a star in the very late stages of its life. It has exhausted the main fuel in its core and has swollen up to an almost unbelievable size. It lies in the constellation Scutum, nearly 9,500 light-years from Earth. When astronomers first began to understand its properties, they were confronted with numbers that seemed to break the rules. Let us try to understand its scales. The most astonishing number is its radius. UY Scuti is estimated to have a radius that is 1,700 times larger than our Sun. Not 170. 1,700. The margin of error on this measurement is large, but even at the low end, it is one of the most voluminous objects ever found. What does this number truly mean? The best way to understand it is to imagine replacing our Sun with UY Scuti. If this star were placed at the center of our solar system, its surface would not just swallow Mercury, it would not just swallow Venus, it would swallow Earth, swallow Mars. The star's physical surface, its edge, would extend out past the asteroid belt and would engulf the orbit of the largest planet in our solar system, Jupiter. Some estimates suggest it might even reach the orbit of Saturn. Our entire inner solar system, the home of all the rocky planets, including our own, would exist comfortably inside this one single star. The sheer size is staggering. If you could fly a commercial jet airplane around its circumference, it would take you 9 hours to complete the trip. But even that fails to capture the scale. Let us use the ultimate speed limit in the universe. Light. Light travels so fast it can circle the Earth 7.5 times in 1 second. It takes that same light just 8 hours to travel across the circumference of UY Scuti. 8 hours for light itself to make 1 lap around this star. By comparison, it takes light only 14 seconds to circle our Sun. UY Scuti is not the most massive star, meaning it does not have the most stuff. But it is by far the largest, the most puffed up. It is a star living out its final, glorious days, shedding its outer layers into space. It is a cosmic behemoth that reminds us that no matter how large our world seems, the universe is always grander, more extreme, and more wonderful than we can possibly imagine. Fact 10. The giant diamond in the sky. In the vast and endless ocean of the cosmos, astronomers have discovered wonders that defy human imagination. From star-birthing pillars of gas to entire galaxies colliding in a silent cosmic dance. For millennia, humanity has looked at the sparkle of distant stars and compared them to the rarest and most beautiful gems on Earth. But nothing could have prepared astronomers for the discovery of a star that is not just like a diamond, but is In fact, one of the largest and most extraordinary diamonds in the entire known universe. This is not science fiction, but the confirmed and astonishing future for stars just like our own sun. The star, a celestial wonder known officially as BPM 37,093, has been affectionately nicknamed Lucy by astronomers. A fitting tribute to the famous Beatles song, Lucy in the Sky with Diamonds. This remarkable object is a special type of star known as a white dwarf, the incredibly dense and cooling remnant of a star that has reached the end of its life. To understand how such a breathtaking object can exist, we must first look at the life and death of stars like our Sun for billions of years. A star like the Sun shines by fusing hydrogen into helium in its core, a process of nuclear fusion that releases a tremendous amount of energy. But this fuel is finite. When a star of this size finally exhausts the hydrogen in its core, its life enters a final, dramatic phase. It swells into an enormous red giant, its outer layers expanding outward, engulfing the inner planets. After this phase, the star's outer atmosphere drifts away, creating a beautiful and complex structure known as a planetary nebula. What is left behind, at the very center of this fading glory, is the star's hot, dense core. This remnant is what astronomers call a white dwarf. It is a star that has effectively died. It no longer generates new heat through nuclear fusion. It is a cooling ember, an object about the size of the Earth but containing the mass of a sun, making it one of the densest forms of matter in the universe. For decades, astronomers had theorized about what would happen to these white dwarfs as they cooled over cosmic time. A white dwarf is composed mostly of carbon and oxygen, the leftover products of the star's lifetime of fusion. This core is held up not by heat, but by a strange quantum mechanical effect known as electron degeneracy pressure, which prevents the star from collapsing in on itself. Because it has no internal energy source, a white dwarf simply radiates its leftover heat into space, a process that takes billions upon billions of years. As the star cools, its interior, which is already under immense gravitational pressure, would begin to change. Scientists predicted that as the temperature dropped, the carbon atoms inside would lock into an ordered crystal lattice. This process is known as crystallization. On Earth, when carbon is subjected to extreme pressure and heat, it forms a diamond. In the core of a cooling white dwarf, the same laws of physics apply. The star, in its final act, would slowly and silently crystallize, transforming from a hot gas into a solid, Earth-sized diamond. This was a remarkable theory, but for a long time it remained just that. Then astronomers turned their attention to BPM 37,093. A white dwarf locates about 50 light-years away from Earth in the constellation of Centaurus. This particular star was special. It is a pulsating white dwarf, meaning it rings like a cosmic bell. These pulsations, or starquakes, send seismic waves traveling through the star's interior. By studying these tiny, rhythmic changes in the star's light, a technique known as astroseismology, astronomers at the Harvard-Smithsonian Center for Astrophysics were able to study the white dwarf's internal structure, much as geologists use earthquakes to study the interior of the Earth. In the year 2004, a team led by astronomer Travis Metcalf announced a stunning discovery. The data from BPM 37093's pulsations showed that its core was not a fluid gas, but had indeed crystallized. The star had frozen over. The scale of this diamond is almost impossible for the human mind to grasp. The star itself is about the size of our planet, but its mass is comparable to our sun's. The crystallized core, this cosmic diamond, is estimated to be a staggering 10 billion trillion carats. This number is so vast that it is effectively meaningless. But it represents a solid crystal of carbon larger than any person has ever dreamed of. This single object contains more carats than all the diamonds ever found on Earth combined, multiplied by a factor of trillions. The discovery of Lucy was more than just a fascinating celestial curiosity. It was a profound confirmation of our understanding of how stars live and die. It provided the first direct observational evidence that white dwarfs do indeed crystallize as they cool. This process is not a rare or exotic one. It is the inevitable and quiet future for a vast number of stars in our galaxy, including our very own sun, billions of years from now. Long after the Earth is gone, our sun will end its life as a white dwarf. It too will slowly cool, and over the vast expanse of time, its core will transform into a giant diamond, a silent, glittering tombstone in the dark, a cold and beautiful monument to the star that once gave life to our solar system. Fact 11. The cosmic void. The universe, as we see it from Earth, appears to be an endless tapestry of light. Our night sky is filled with the pinpoint glow of stars, the soft smudge of the Milky Way, and through our most powerful telescopes, the faint, ghostly shapes of distant galaxies. We have grown accustomed to the idea that the cosmos is a crowded place, filled with matter, energy, and countless worlds. But astronomers have discovered that this is only part of the story. The structure of the universe is not uniform. Gravity has, over the course of 13.8 billion years, sculpted the cosmos into a vast and intricate structure known as the cosmic web. This web is made of long, delicate filaments of galaxies and dark matter, which meet at dense, busy intersections where massive galaxy clusters form. But this web-like structure implies something else. If all the matter is being pulled into these filaments and clusters, what lies in the spaces in between? The answer is one of the most unsettling and astonishing discoveries in modern astronomy. The universe is also defined by its vast, almost unimaginable emptiness. These near-empty regions are known as cosmic voids, and among them one stands out as a true titan of nothingness. It is called the Boat's Void, a name that invokes its location in the constellation Boats, but it is more famously known by its chilling nickname, the Great Nothing. This region of space is not just slightly empty. It is a profound and staggering desert, an ocean of darkness that challenges our very perception of the cosmos. The void was first discovered in the year 1981 by a team of astronomers including Robert Kirshner, Zomia Jr., Paul Schechter, and Stephen Schechtman. They were in the process of conducting a redshift survey of galaxies, a painstaking method of mapping the three-dimensional structure of the universe by measuring how the light from distant galaxies has been stretched by cosmic expansion. As they mapped a patch of sky in the direction of Boats, they kept finding nothing. Their surveyed data revealed a vast, spherical region of space that was almost completely devoid of galaxies. The sheer scale of the boat's void is what makes it so extraordinary. This spherical region is estimated to be roughly 330 million light-years in diameter. This distance is so large that it becomes almost abstract. To put it in perspective, our own Milky Way galaxy is about 100,000 light-years across. The distance to our nearest major galactic neighbor, Andromeda, is about 2.5 million light-years. One could line up more than 130 Andromeda galaxies end-to-end to cross this single empty expanse. Based on the average density of the universe, a region of space this large should contain thousands, perhaps even more than 10,000 individual galaxies. It should be a bustling neighborhood of cosmic structures. And yet, when astronomers first peered into its depths, they found almost none. The initial survey found only 8 galaxies in a region that should have held thousands. This discovery was so shocking that the astronomers were initially skeptical, wondering if their equipment was faulty. But further observations confirmed the terrible emptiness. This void is the ultimate cosmic ocean. The vibe that it evokes is one of profound, quiet isolation. To truly grasp its nature, one must imagine being placed in its center. If our own Milky Way galaxy were located in the middle of the boat's void, our entire understanding of the universe would be different. From Earth, our night sky would be almost perfectly black. We would see the stars of our own galaxy, but the familiar, faint smudges of distant galaxies like Andromeda or Triangulum would be completely absent. They would be too far away to see. In fact, if humanity had evolved in such a place, we would have had no observational evidence of other galaxies until the development of advanced radio telescopes in the 1960s. For all of human history, we would have believed that our Milky Way was the entire universe, alone in an endless, cold, and empty void. The feeling would be one of ultimate loneliness. Since its discovery, more sensitive surveys have been conducted, and astronomers have managed to find a few more residents of this great nothing. The current count of known galaxies within the void is approximately 60. While this is more than the original 8, it is a comically small number compared to the 10,000 or more that are missing. These 60 galaxies are not scattered randomly, but seem to form a faint, tube-like filament of their own, snaking through the center of the emptiness, a tiny, fragile stream in an overwhelming desert. So, how does such a place come to be? The boat's void is not a supernatural anomaly, but rather an extreme and fascinating example of how the universe's structure evolves. Voids are a natural and necessary part of the cosmic web. Over billions of years, the relentless pull of gravity has drawn matter gas, dust, and galaxies into the filaments, like water gathering into streams. The regions left behind, where the initial density of matter was slightly lower, were left out. Their matter was pulled away, leaving them to grow emptier and emptier. The boat's void is thought to be an extreme case, where several smaller voids, which formed separately, eventually merged into one supervoid. It is not a perfect vacuum. It is still filled with a faint, diffuse radiation of the Big Bang, and likely contains dark matter and thin, wispy hydrogen gas. But it is a place where creation on a galactic scale has all but ceased. The great nothing is a humbling reminder that the universe is defined as much by its silence, and its emptiness as it is by its light and its glory. Fact 12. The coldest place in the universe. In the immense and cold darkness of deep space, there is a fundamental temperature, a faint, lingering warmth that bathes the entire universe. This is the cosmic microwave background, or CMB, the ancient afterglow of the Big Bang itself. This radiation, which comes from every direction in the sky, has cooled as the universe has expanded over 13.8 billion years, and it now has a uniform temperature of approximately 2.7 Kelvin. That is 2.7 degrees above absolute zero, the theoretical point at which all atomic motion ceases. This faint energy acts as a background temperature for the cosmos. Nothing in the universe, it was thought, could naturally become colder than this background glow. After all, the CMB bathes everything, gently warming it. And yet, in the year 1995, astronomers discovered a place that defies this rule. A place that is actively chilling itself to a temperature even lower than the faint echo of creation. This is the Boomerang Nebula, the coldest natural place ever discovered in the known universe. The Boomerang Nebula, located about 5,000 light-years from Earth in the constellation Centaurus, is a breathtaking object known as a pre-planetary nebula. This is a fleeting and dramatic stage in the life of a star much like our Sun, but perhaps slightly more massive. It is a star in its final death throes, having shed its outer layers of gas into space. When it was first observed in 1980 by astronomers from an observatory in Australia, it showed a faint, asymmetric, or boomerang-like shape, which gave the object its name. But it was not until 1995, when astronomers used the Swedish SO submillimeter telescope in Chile, that its most remarkable secret was revealed. They were studying the nebula at submillimeter wavelength, which are ideal for measuring the temperature of cold gas, and they found something that seemed impossible. The gas in the Boomerang Nebula had a temperature of only 1 Kelvin. This temperature is extraordinary. 1 Kelvin is equivalent to minus 272.15 degrees Celsius, or minus 457.87 degrees Fahrenheit. This is just 1 single degree above absolute zero, the lowest temperature physically possible. It is a place of almost perfect, unimaginable cold. But the most shocking fact was that this temperature was significantly colder than the cosmic microwave background. The Boomerang Nebula was not just cold. It was actively absorbing the background warmth of the universe, making it appear as a shadow or a dark spot against the faint glow of the Big Bang. This discovery presented a fascinating puzzle. How could this object become so incredibly cold? The answer, astronomers found, was that the nebula was not just passively cooling. It was, in effect, a cosmic refrigerator, using its own energy to chill itself to this extreme temperature. The mechanism behind this deep freeze is a process known as adiabatic expansion, a principle of thermodynamics that is familiar to anyone who has used a can of compressed air. When you spray the can, the compressed gas expands rapidly as it escapes the nozzle, and the can itself becomes noticeably cold. The gas is doing work as it expands, and it draws the energy for that work from its own internal heat. causing its temperature to drop dramatically. The Boomerang Nebula is this same principle taken to a cosmic extreme. The dying star at its center is ejecting its gas and dust not in a gentle, drifting puff, but in a violent and incredibly rapid outflow. The gas is streaming away from the star at an astonishing speed of nearly 164 kilometers per second, which is more than 367,000 miles per hour. This expansion is so fast and so powerful that the gas is doing an enormous amount of work as it pushes out into space. In doing so, it is self-shilling at an incredible rate, using up its own thermal energy and plummeting to a temperature far below what would normally be possible. Later, more detailed observations of the Boomerang Nebula by the Hubble Space Telescope in 1998 revealed its true shape and provided more clues to its nature. The iconic boomerang shape seen by ground-based telescopes was revealed to be a much more intricate and beautiful bow tie or hourglass structure. This is known as a bipolar nebula, where the star ejects material in two opposing jets. We are seeing this hourglass shape from a slightly tilted angle, which created the illusion of a curved boomerang. Hubble's sharp vision revealed intricate glowing arcs and filaments in the gas, sculpted by the shock waves of the outflow. This violent ejection of matter is not a gentle process. The star is losing mass at a furious rate, shedding the equivalent of our sun's mass over a period of only 10,000 years, and it has been doing this for at least 1,500 years. This object is a unique and vital laboratory for understanding the final, chaotic stages of a star's life. The rapid expansion that creates this ultra-cold temperature is a fleeting phenomenon, lasting only a few thousand years before the central star becomes hot enough to ionize the surrounding gas, transforming the structure into a more familiar, glowing planetary nebula. The Boomerang Nebula, therefore, is more than just a record holder for cold. It is a snapshot of a violent and beautiful transition, a star's final, gasping breath. In its dramatic and powerful death, this star has created the most frigid place known to science, a region of space that is colder than the darkness it inhabits. A chilling monument to the awesome and sometimes counterintuitive power of physics on a cosmic scale. Fact 13. The Forge of Creation. In the silent depths of the cosmos, we often look to the brilliant hearts of stars as the engines of power and light, the hottest places in the universe. But nothing in the life of a star can compare to the unfathomable heat generated in the final, catastrophic moment of its death. The true hottest place in the universe is not a living star, but the core of a massive star as it explodes, a phenomenon known as a supernova. This single, fleeting event, lasting only a split second, unleashes a torrent of energy so vast that it rewrites the story of cosmic chemistry, forging the very elements that make up our world. To understand this incredible moment, we must first look at the long, stable life of a star far more massive than our own sun. For billions of years, such a star is a giant nuclear furnace. Deep in its core, it wages a constant battle between the inward crush of its own gravity and the outward push of the energy released by nuclear fusion. This process begins by fusing hydrogen atoms into helium, releasing the light and heat that make the star shine. As the hydrogen runs out, gravity compresses the core further, raising the temperature until helium atoms begin to fuse into carbon. This cycle continues, with the star creating a layered, onion-like structure. It builds heavier and heavier elements in its core. Carbon fuses into neon, neon into oxygen, oxygen into silicon. Each stage is hotter and shorter than the last, a frantic race against the inevitable victory of gravity. This cosmic alchemy, however, has a final limit. The process of fusion continues until the star's core is composed of iron. Unlike all the elements that came before it, the fusion of iron into heavier elements does not release energy. It consumes it. When the core becomes choked with iron, the star's energy source is suddenly shut off. The outward pressure that held gravity at bay for millions of years vanishes in an instant. In this catastrophic moment, gravity wins. The star's core, which may be the size of the Earth but hold the mass of our Sun, collapses in on itself at astonishing speeds, reaching nearly a quarter of the speed of light. This is the moment the universe's greatest furnace is lit. As the core implodes, the particles are crushed together with such violence that the temperature skyrockets. For one brief, extraordinary split second, the core's temperature reaches an almost unimaginable 100 billion degrees Celsius, or 180 billion degrees Fahrenheit. This is thousands of times hotter than the center of our Sun. The core becomes so dense that atomic nuclei are squeezed together, and the collapse is suddenly halted. The core bounces. This rebound sends a titanic shockwave hurtling outward through the star's collapsing outer layers. It is here, in this impossibly hot, chaotic environment of the exploding star, that the universe creates its most precious materials. The shockwave and the intense flood of energy from the collapsing core provide the perfect conditions for a process called supernova nucleosynthesis. This is the calm story of creation hidden within the violent. The energy is so great that iron nuclei are blasted apart and also capture other particles, rapidly building elements heavier than iron in a fraction of a second. This single, final explosion is responsible for forging the vast majority of the heavy elements in the universe. The expanding cloud of debris, rich with newly created elements, spreads out into interstellar space, seeding the surrounding galaxy. This cloud, a supernova remnant, will eventually cool and congeal, forming new clouds of gas and dust. From these enriched clouds, new generations of stars and planets will be born. The gold in a ring, the silver in a coin, the calcium in our bones, and the iron in our blood were all created in the heart of one of these ancient, cataclysmic explosions. The death of one massive star provides the raw material for countless new worlds and ultimately for life itself. When we look at the intricate beauty of an object like the Crab Nebula, we are not just seeing the ghost of a star that exploded in the year 1054. We are looking at the cradle of the elements, a testament to the universe's profound and violent cycle of death and rebirth. Fact 14. The cosmic Leviathan. In the vast cosmic ocean, there are monsters. They are not creatures of myth, but objects of pure gravity, sitting silently in the dark, patiently waiting. Astronomers have long studied the supermassive black holes that lie at the heart of nearly every large galaxy, including our own. But one of these objects dwarfs all others, a true cosmic leviathan, so massive it challenges our understanding of how such things can even exist. This object is known as Stun 618. It is, by a wide margin, the largest and most massive, supermassive black hole ever discovered by humanity. To comprehend the scale of this monster, we must first establish a baseline. Our own galaxy, the Milky Way, has a supermassive black hole at its center named Sagittarius A star. It is an object of immense power, with a mass of roughly 4 million times that of our Sun. For decades, astronomers believed this was the standard for a large galaxy. But Ton 618 exists on a completely different level, located at the center of a distant, unnamed galaxy. In the constellation Canes Venatici, TON 618 has an estimated mass of 66 billion times the mass of our Sun. It is not just a supermassive black hole. Astronomers classify it as an ultramassive black hole, a category reserved for the most extreme objects in the cosmos. This incomprehensible mass creates a gravitational influence that is difficult to picture. Every black hole is defined by its event horizon, the theoretical shadow or boundary from which nothing, not even light, can escape. This is the point of no return. For a black hole of Ton 618's mass, the event horizon is staggeringly large. Its diameter is estimated to be so vast that our entire solar system, measured all the way out to the orbit of Pluto, could fit inside it 11 times over. Sidbisire. If it were to replace our Sun, its shadow would extend far beyond the most distant planets, swallowing the entire system whole. The story of its discovery adds to its mysterious nature. When it was first catalogued in the year 1957 from the Tonantzintla Observatory in Mexico, astronomers had no idea what it was. On photographic plates, it appeared as a faint blue star, and it was given the designation Tonantzintla 618. It was not until the 1970s, as scientists studied the sky with radio telescopes, that its true nature was revealed. TON 6018 was not a star in our galaxy at all, but one of the brightest objects in the entire universe, located an incredible distance of over 10 billion light-years away. What we are seeing is not the black hole itself, as it emits no light. Instead, we are seeing the light of its feeding process. TON 6018 is a quasar, which is short for quasi-stellar radio source. A quasar is an active galactic nucleus, meaning the supermassive black hole at its center is actively consuming enormous amounts of gas, dust, and stars. As this material spirals into the black hole, it forms a vast, superheated disk known as an accretion disk. The friction and gravitational energy within this disk heat it to billions of degrees, causing it to shine with a light that outshines its entire host galaxy thousands of times over. The light we see from Ton 618 is the death scream of matter as it is consumed by the Leviathan. The very existence of Ton 618 is a profound puzzle for astronomers. Because it is over 10 billion light-years away, we are seeing it as it was over 10 billion years ago, when the universe was less than a third of its current age. How could a black hole grow to 66 billion solar masses so quickly after the Big Bang? Our current models of black hole formation, which involve smaller black holes merging over eons, struggle to explain the formation of such a monster so early in cosmic history. It suggests that the early universe may have had mechanisms for creating seeds of giant black holes, allowing them to grow much faster than previously thought. TON 618 sits in the distant cosmos not just as an object of immense size, but as a quiet, respectful reminder that our understanding of the universe is far from complete, and that giants truly did walk in the cosmic dawn. Pact 15. The invisible skeleton for all of human history. Our understanding of the universe was based on what we could see. We looked up at a sky filled with the brilliant light of stars, the ghostly glow of nebulas, and the majestic islands of distant galaxies. We built powerful telescopes like Hubble and the James Webb Space Telescope to see farther and deeper, collecting the faint light from the edge of creation. But one of the most profound and humbling discoveries of modern astronomy is this. All of it, everything we have ever seen, is just a tiny fraction of what is actually out there. All the stars, all the planets, all the gas, dust, and all the forms of life, everything we can see and touch, makes up less than 5% of the total contents of the universe. The cosmos is dominated by two mysterious, invisible substances that we have only come to know by their effect. The vast majority of the universe, about 68%, is believed to be dark energy, a strange, repulsive force that seems to be embedded in the fabric of space itself, pushing the universe apart at an ever-accelerating rate. But the other component, which makes up about 27% of the universe, is something just as mysterious: dark matter. While dark energy pushes things apart, dark matter pulls things together. It is the invisible gravity, the cosmic scaffolding, the silent, unseen skeleton that holds the visible universe in place. We cannot see dark matter. It does not emit, absorb, or reflect any light. It is not dark in the way a cloud of dust is dark. It is fundamentally invisible. It does not interact with regular matter, which astronomers call baryonic matter, in any way except through the persistent, gentle pull of gravity. And yet we know it is there. The evidence for its existence is overwhelming, and it was first glimpsed in the 1930s by the brilliant and eccentric astronomer Fritz Zwicky. While studying the Coma cluster of galaxies, Zwicky noticed something impossible. The individual galaxies within the cluster were moving at tremendous speed, so fast that their mutual gravity should not have been nearly strong enough to hold the cluster together. It should have flown apart like a breaking flywheel. Zwicky proposed that there must be an enormous amount of unseen dunkel materie, or dark matter, providing the extra gravitational glue. His observation was largely ignored for decades, until the 1970s, when the astronomer Vera Rubin provided the smoking gun. She was studying the rotation of spiral galaxies, like our own Milky Way, according to the laws of gravity. Just as planets farther from the sun orbit slower, stars at the edge of a galaxy should move much slower than stars near the bright center, where most of the visible mass is. But that is not what Vera Rubin found. Instead, she discovered that the stars at the very edges of galaxies were moving just as fast as the stars near the center. This galaxy rotation curve made no sense. The only way to explain it was if the entire galaxy was embedded in a massive, invisible halo of dark matter, whose gravity extended far beyond the visible stars, keeping them in their high-speed orbits and preventing them from spinning apart. Since then, astronomers have found its fingerprints everywhere. We see its effect through a phenomenon called gravitational lensing. This occurs when the immense gravity of a massive object, like a galaxy cluster, bends the fabric of space around it. This warped space acts like a lens, distorting and magnifying the light from even more distant galaxies located behind it. By measuring the amount of distortion, astronomers can create a map of all the mass in the cluster. These maps clearly show a vast, invisible structure of dark matter that perfectly matches the predictions, a gravitational skeleton that the visible galaxies are clinging to. Dark matter is not just a modern curiosity. It is the reason we exist at all. By studying the faint afterglow of the Big Bang, known as the cosmic microwave background, scientists have confirmed that the early universe was incredibly smooth. The tiny seeds of structure that would eventually become galaxies would not have had enough gravity to pull together on their own. It was the dark matter already present that formed the first gravitational wells, attracting the normal baryonic matter and allowing it to clump together to form the first stars and galaxies. We live within a vast, invisible, cosmic web of dark matter, and what we see as a galaxy is just the visible foam glowing on the surface of a deep, unseen ocean. Fact 16. The invisible push for decades. Astronomers asked one of the most fundamental questions about our universe. What is its ultimate fate? For most of history, scientists assumed that the universe was static, an unchanging stage upon which the drama of stars and galaxies played out. Then, in the 1920s, astronomers like Edwin Hubble revealed a shocking truth. The universe was not static at all. It was expanding. The galaxies were all rushing away from each other, like shrapnel from a cosmic explosion. For the rest of the 20th century, the debate raged on. Would the universe expand forever, growing colder and darker until it ended in a big freeze? Or would the combined gravity of all the matter within it eventually act as a brake, slowing the expansion down and pulling everything back together in a fiery big crunch? Everyone assumed the expansion must be slowing down. Gravity, after all, only pulls. It does not push. But nothing could have prepared them for what was discovered in 1998. Two separate teams of astronomers, using powerful telescopes to study distant, exploding stars, found something that defied all logic. The expansion of the universe was not slowing down. It was speeding up. What exactly was this mysterious force that was pushing the universe apart? And why is it rewriting the story of cosmic history? Scientists have given this force a name: dark energy. It is one of the most profound and baffling mysteries in all of science. When astronomers measure the total amount of stuff in the universe, they find that the stars, the galaxies, the planets, and even you and I, all the matter we can see, touch, and understand, makes up less than 5% of the cosmos. Another 27% is thought to be dark matter, an invisible substance whose gravity holds the galaxies together. But the rest of the universe, a staggering 68%, is something else entirely. This means that more than 2/3 of all of reality is this unknown energy, this invisible push. This force acts as a kind of anti-gravity. While gravity pulls matter together, this dark energy pushes the very fabric of space apart. It is a strange force, a cosmic pressure that seems to be embedded in the vacuum of space itself. As the universe expands, more space is created. And with that new space comes more of this dark energy, which in turn pushes space to expand even faster. It is a runaway effect, a cosmic acceleration that is stretching the fabric of space itself. The discovery of this force was so profound that it awarded its discoverers the Nobel Prize. They had found that our universe is not destined for a big crunch, but is instead being relentlessly pushed apart by an invisible majority. How did they find this? Scientists used exploding stars known as Type 1a supernova. These explosions are what astronomers call standard candles, meaning that they always detonate with the same predictable brightness. Because scientists know how bright they actually are, they can measure how bright they appear from Earth to calculate their distance. It is like seeing a 100-watt light bulb in the distance. The dimmer it appears, the farther away it must be. When astronomers looked at these standard candles in the most distant galaxies, they found they were dimmer than expected. This meant they were farther away than all the models predicted. The only way they could be that far away is if the universe's expansion had sped up in the billions of years. It took their light to reach us. This dark energy is a deep mystery. We can see its effect, this accelerating expansion, but we do not know what it is. Is it a property of space itself? What Albert Einstein once called the cosmological constant? Or is it a new, unknown energy field that fills all of space? A force that scientists have called quintessence. Whatever it is, this strange and invisible force, this 68% of the cosmos, holds the ultimate fate of our universe in its hands. It is a quiet, relentless push that is stretching our cosmos apart, making the galaxies grow more and more distant, until one day, trillions of years from now, they will have all been pushed so far away that the night sky will be left completely dark and empty. Fact 17. The sound of the Big Bang in the year 1964. Two young astronomers named Arno Penzias and Robert Wilson were working at Bell Labs in New Jersey. They were using a large, horn-shaped radio antenna to study signals from the Milky Way galaxy. But they had a problem. No matter where they pointed their antenna, they detected a faint, persistent, and annoying hiss of static. It was a noise that came from every direction in the sky, day and night, through every season. They checked their equipment, rewired their systems, and even cleaned the antenna, removing what they famously described as a white dielectric material, otherwise known as pigeon droppings. But the hiss remained. They were completely stumped. What they had accidentally discovered was not noise from Earth or from pigeons, but the oldest sound in the universe. They were hearing the echo of creation itself. This faint hiss of static, which is found everywhere in the universe, is now known as the cosmic microwave background, or the CMB. It is the leftover heat, the fading afterglow of the Big Bang. This light began its journey across space 13.8 billion years ago, not long after the universe itself was born. It is the most ancient light we can detect, a fossil remnant from the dawn of time. If you have an old analog television and you tune it to an empty channel, the snow and static you see on the screen is not just random noise. About 1% of that static, 1% of that hiss, is the cosmic microwave background. You are, in a very real sense, seeing and hearing the leftover radiation from the Big Bang. To understand what this is, we must go back in time. For the first 380,000 years after the Big Bang, the universe was not as we see it today. It was an unimaginably hot, dense, and chaotic place. It was not dark. It was filled with a blinding, white-hot fog of plasma, a soup of particles and energy so dense that light could not travel through it. Any photon of light was immediately scattered by a free-flying electron, trapped in an endless game of cosmic pinball. Then, as the universe expanded, it cooled. When it reached an age of about 380,000 years, it became cool enough for the first atoms to form. Electrons were finally captured by protons, creating stable hydrogen. This moment, which scientists call recombination, changed everything. Suddenly, the universe, which had been an opaque fog, became transparent. The light that had been trapped inside that fog was finally set free, and it began to stream across the cosmos, unhindered in all directions. That light has been traveling ever since, for nearly 13.8 billion years. As it traveled, the universe continued to expand, and this expansion stretched the light wave. The light that was once blindingly hot and visible has been stretched all the way down the electromagnetic spectrum, past red light, past infrared, until today it exists as very cold, very faint microwaves. This ancient light now has a temperature of just 2.7 degrees above absolute zero. This hiss is more than just an echo. When scientists use sensitive satellites like the COBE, WMAP, and Planck spacecraft to map this radiation, they found it was not perfectly uniform. It is filled with tiny, microscopic variations in temperature. These tiny hot spots and cold spots are the most important discovery in modern cosmology. They're the seeds of creation. The slightly denser spots, the cold spot, were the places where gravity had just a little more pull. Over hundreds of millions of years, gravity pulled these denser regions together, forming the very first stars, the first galaxies, and eventually the great cosmic web of clusters we see today. That faint 1% of static on an old television is not just noise. It is a baby picture of the universe. It is the blueprint for everything we know. The oldest story ever told, the faint, lingering sound of the Big Bang. Fact 18. The galaxy of rogue planets. When we look up at the night sky, we see a familiar pattern. We see stars, and we know that those stars, like our own sun, are often orbited by families of planets. These planets are locked in a gravitational dance, with their parent star drawing heat and light from its fiery surface. Our solar system is a place of order, a collection of worlds anchored to a central star. But our galaxy is also home to a different, more mysterious, Kendorf world, deep in the cold, dark void between the stars. There are planets that do not orbit a star at all. They are cosmic orphans, rogue planets, floating alone in the dark. These lonely worlds, also known as free-floating planets or nomad planets, are drifting silently through the galaxy. They are planets in permanent night, worlds without a sun, without a sunrise or a sunset. They are bound to no star system, traveling on a solitary journey through the interstellar darkness. For a long time, these were just a theory, a ghostly possibility. But in recent years, astronomers have confirmed that they are not only real, but they are also incredibly common. How common are they? The numbers are astonishing. Scientists now estimate that there could be billions, or even trillions, of these lonely worlds in our galaxy alone. The most conservative estimates suggest there are at least as many rogue planets as there are stars, but many models predict they could far outnumber the planets that are safely orbiting stars. For every single planet like Earth or Jupiter that we find in a solar system, there could be 20 or 50, or even 100 of these rogue planets drifting through the vast, empty spaces between. The Milky Way, it seems, is teeming with these hidden, sunless worlds. Where do these planets come from? Astronomers believe there are two main ways a rogue planet can be born. The first is a violent birth. A planet can form in a normal solar system, just like the planets in our own. But in the chaotic early days of a system's life, the gravitational pull of other planets, especially massive gas giants, can create a kind of celestial slingshot. A smaller, Earth-sized or Mars-sized planet can be kicked so hard by a gravitational encounter that it is thrown out of the system entirely, ejected into interstellar space to wander forever. The second method is a lonely birth. In a vast, cold cloud of gas and dust, a small clump might begin to collapse under its own gravity. If the clump is massive enough, it will ignite as a star. But if it is too small, it will fail to ignite. It will simply collapse into a dark, planet-sized object. A world that was born in the darkness, never to know the light of a parent star. Finding these worlds is incredibly difficult. They are almost completely invisible. They do not shine with their own light, and they have no star to reflect light from. They are cold, dark, and solitary. Astronomers must use a clever technique to find them, a method predicted by Albert Einstein known as gravitational microlensing. This phenomenon occurs when a massive object, such as a rogue planet, passes perfectly in front of a much more distant, unrelated star. The rogue planet's gravity, though small, is still powerful enough to bend the fabric of space around it. This creates a cosmic magnifying glass. As the rogue planet drifts by, its gravity bends and focuses the light from the background star, causing that star to appear to briefly get brighter and then fade away. This blip of light, lasting for a few hours or a few days, reveals the presence of the invisible rogue planet that passed in front. What are these worlds like? They are the definition of a sleepy description of a planet in permanent night. The surface would be unimaginably cold, frozen solid by the near absolute zero temperature of deep space. But that does not mean they are lifeless. If a rogue planet is large enough, it might have a thick hydrogen atmosphere that could trap its own internal heat left over from its formation. This internal geothermal energy could be enough to maintain a vast, liquid water ocean underneath a crust of ice hundreds of miles thick, much like the suspected oceans on Jupiter's moon Europa. These trillions of hidden worlds, drifting in the eternal night, represent a vast, undiscovered population of the galaxy. A silent majority, reminding us that the cosmos is filled with more wonders than we can possibly see in the light. Fact 19. The eerie silence in the grand and silent cosmos. Humanity has spent decades listening, pointing vast mechanical ears toward the darkness, hoping to catch a single, faint whisper that is not our own. For all that time, the universe has offered only a steady, cold hiss, the ancient static of creation itself. But for one brief, astonishing moment, the silence was broken. On an otherwise ordinary night in 1977, something spoke from the void. A single, powerful, and unexplainable signal that remains our most profound and tantalizing mystery. It is known to history not by a complex designation, but by the simple, human word of shock scrawled on its record: the WOW signal. The story begins at the Ohio State University Radio Observatory, home to a remarkable instrument known as the Big Ear. This was not a modern, sleek dish, but a massive, stationary telescope that used the rotation of the Earth itself to scan the heavens. In the month of August, in the year 1977, the telescope was conducting its usual survey, patiently listening to the sky. The astronomer, Dr. Jerry R. Emmon, was not present for the event itself. His discovery would come days later, on August 15th, as he performed the routine task of reviewing the reams of computer printout data the telescope had recorded. The data was a simple grid of letters and numbers, each representing the intensity of radio signals received from different points in the sky. Most of the printout was a monotonous stream of ones and twos, the signature of faint, natural background noise. But as Emmon's eyes scanned the columns, he saw something that made him stop. There, in the middle of the noise, was a sequence that did not belong. It read 6EQUJ5. In this coding system, the numbers 1 through 9 represented rising intensity, and the letters A through Z represented even stronger signals beyond that. What Emmon saw was a signal that had risen from the background noise, peaked at a staggering intensity, and then faded away, precisely as a signal from deep space would. The sequence 6EQUJ5 was a perfect bell curve, a cosmic shout. The signal, whatever it was, had lasted for a total of 72 seconds. This number is the most crucial clue, as 72 seconds was the exact amount of time it took for the Big Ear, fixed in place, to observe any single point in the sky as the Earth turned. It was not a glitch, nor was it a plane, nor was it a satellite from Earth. It bore all the hallmarks of a true interstellar beacon. The signal's power was just as astonishing. At its peak, represented by the letter U, it was more than 20 times stronger than the normal background noise of the universe. This was not a subtle whisper. It was a clear, strong, and unambiguous transmission. But its most compelling feature was its frequency. It was broadcast at almost exactly 1,420 megahertz. This specific frequency is sacred to radio astronomers, often called the waterhole. It is the natural frequency at which neutral hydrogen, the most common element in the universe, broadcasts. It is a protected, quiet channel, free of cosmic noise. And it is the exact frequency that scientists have long theorized any intelligent civilization would choose if they wanted to send a message across the stars. It was, in every way, the perfect signal. It came from a seemingly empty patch of sky in the constellation Sagittarius, a region near the dense, star-filled heart of our own Milky Way. Dr. Emmon was so stunned by the perfect match of all these characteristics that he circled the sequence in red ink and wrote a single word in the margin: "Wow." And then, as suddenly as it appeared, it was gone. In the decades since 1977, Astronomers have returned to that exact spot in the sky, again and again, with telescopes far more powerful and sensitive than the Big Ear. They have found nothing. The signal has never been heard again. It was not a pulsar, not a known stellar event, and not any known terrestrial interference. It remains a single 72-second long event. It was a calm, powerful, and unexplainable hello from the void. An eerie silence that followed a shout, leaving humanity to wonder forever. Who or what was out there, and why they spoke only once. Fact 20. The final number in our search for meaning in the cosmos, we often turn to the tangible, the things we can touch and count. We think of a single grain of sand held in the palm of the hand. We imagine a beach, a shoreline covered in countless particles. And then we try to imagine all the beaches on every continent, all the deserts and all the ocean floors. We try to comprehend the staggering number of all the grains of sand on the entire planet Earth. It is a number so vast it borders on the philosophical. And yet the universe offers a number that dwarfs it, a final, humbling figure that provides the ultimate perspective. The fact is simple. There are more stars in our observable universe than there are grains of sand on all the beaches of our world. To understand this, we must begin at home. Our galaxy, the Milky Way, is a single island of light in the cosmic ocean. It is our home, a vast, swirling disk of gas, dust, and stars. The numbers for our own galaxy are already difficult to comprehend. Astronomers estimate that the Milky Way contains between 100 billion and 400 billion stars. Our Sun is just one of them, one of hundreds of billions. This number, 400 billion, is already greater than the number of all humans who have ever lived. If each of those stars were a single grain of sand, our galaxy alone would be enough to fill a vast stretch of coastline. But the true scale of the cosmos was revealed when humanity pointed its most powerful telescopes. Like the Hubble Space Telescope and later the James Webb Space Telescope, at a patch of sky that seemed utterly black and empty. They held that gaze, collecting faint, ancient light for hundreds of hours. When the image was revealed, it was not empty. It was filled to the brim with light. But these were not stars. Each tiny smudge, each faint swirl of color, was an entire galaxy. A Milky Way in its own right, each one containing its own billions or even trillions of stars, based on these deep field images. Astronomers have calculated the number of galaxies just in the part of the universe we can see, what is known as the observable universe. That number is estimated to be 2 trillion. 2,000 billion galaxies, each an island universe, each with its own family of stars. Now we must do the final calculation. If there are, on average, 100 billion stars in each of those 2 trillion galaxies, the total number of stars in the observable universe is a figure that defies imagination. It is a 1 followed by 24 zeros. 1 second. A number so large we have no human scale comparison for it. The estimated number of grains of sand on all of Earth's beaches is a 1 followed by roughly 19 zeros. This means that for every single tiny grain of sand on our entire planet, there are thousands of stars. For every grain, 1,000 suns. 1,000 potential solar systems, 1,000 opportunities for light. This is the final, soothing thought. The universe is not a vast, empty void. It is a place of overwhelming, astonishing abundance. It is a perfect, vast, and humbling number to fall asleep to. A reminder that the darkness of the night sky is not an emptiness, but a tapestry so full of light that our minds can barely begin to count the threads.